We're going to look at graphing a system of inequalities, linear inequalities. So we need to take two inequality lines, get lazy, and put them on one graph. And then we're going to see where those two graphs end up overlapping each other. Okay, so first, I want to try and make sure both my inequalities are in slope-intercept form, y equals mx plus b. We're good so far over here. They both say y equals. So looking at the top one, I always want to start with my y-intercept. In this case, it's 1. So I'm going to plot that first. Then I need to move using my slope. And in this case, it's going to be -2/1. So that means I'm going to rise -2, I'm going to run 1. So rising -2 means going down 1, 2, and running 1. I can keep going, go down 2/1. Now I'm out of space. I can go in the reverse. Instead of going down and to the right, I can go up 2 and to the left. And okay, we have our dots. They all look like they're going in line with each other. That's fine. That's good. Now, before I connect them, before I draw my line, I got to ask, is it going to be a solid or a dashed line? Well, do you see an equal sign in this top problem? No. So if there's no equal sign, that means it's got to be dashed. So, dashed line. All right. Now we also need to shade. We need to color in either the bottom left or this top right. In order to do that, I'm going to pick a point, any point, as long as that point is not on my dashed line. So I can pick 0, 0 here. I know it's close. I know it's very close to being on that line, but it's just over on that side of the fence. So I want to take 0, 0, x and y, and substitute them in for x and y up here. And let's see what happens. So I'll say 0 less than -2 times 0 plus 1. Is 0 bigger than 1? Is 0 bigger than 1? No. That's not correct. That's wrong. We did the work correct, but the statement is wrong. If that's wrong, that means that's got to be wrong. And if this side is wrong, we know the other side has to be correct. So when I color everything in, I'm going to color in everything up this way. And I'm going to take it very easy so far. I'm not going to go crazy with this yet. Let's look at the second one. Y is less than or equal to x plus 3. My slope is going to be 1, change to a fraction, 1/1. Y-intercept, 3. Find your y-axis, find 3 on it. 1, 2, 3. I want to rise 1, run 1. So I'm going to go up and to the right, up and to the right, up and to the right. And I can also go in the reverse, down and to the left, down and to the left. All of those points, all of those coordinates look like they're in line, which is good. We now need to connect them. But before we connect, we have to ask ourselves, will it be a solid or a dashed line? I see an equal sign. Equal sign means solid. So let's connect them. And I know this is starting to get a little sloppy, but let's try and deal. We have our line. We now need to shade. Pick a point, any point, as long as it's not on the blue line. All I care about is this line. I don't care about anything else. So I'm going to pick 0, 0 again. Clean that up a little. So I want 0, 0 again. Now I know 0, 0 is on this part of the blue line. I want to see if this is true. So I'm going to take this, my x and y, and plug it in. So I'm going to get 0 less than or equal to 1 times 0 plus 3. Is 0 smaller than or equal to 0 plus 3? Is 0 smaller than 3? Or is 3 larger than 0? You can look at this in both ways. Think of it as an alligator. The alligator eats the biggest number. Is this alligator eating the biggest number, 3? Yes, that makes sense. I like this. That's true. That means that's true for this line we just drew. So now everything from this line down is going to get colored in. Okay, so I could do all this, but I don't know if that really does anything. Now I'm doing everything up there. Okay, so my answer, my solution to a system of inequalities is where my two graphs end up overlapping each other. I've got a mess over here. I want to kind of clean this up. I want to see where we overlap. Well, let's look at this top corner up here. I only see these green lines. That doesn't help me. That is not an answer. Back here, I have nothing. Not an answer. Down in this bottom corner, I only see, so I've got my green dashed line, I got a blue solid, but I only see a blue solid line. That doesn't do anything for me. But when I look up here, I've got green going that way, I've got blue coming this way. I see both of them overlapping each other in this corner. My solution is taking this and exaggerating, going crazy, coloring this whole thing in nice and ugly. My answer is everything colored in right now. All of this black is an answer. Yes. So if I were to put a few dots on here, a few coordinates, if I said that coordinate right in the middle, is it a solution? Yes. Why? Because it's in the colored in area where both overlap. If I said right here, is that an answer? Is that a solution? Yes, it is. Why? Because it's on one of the shaded regions, but it's also on a solid line. I like that. That's an answer. Coordinate up here. There's nothing shaded in. Not an answer. One more. I see a coordinate that I already drew. I already drew that. It's on one of the lines. Now, is that a solution to this system? No. Why? Because it ends up landing on one of the dashed lines. And what's happening is all of this black, as it goes up and creeps to this blue line, yes, it hits that line, everyone's happy. It's an answer. But when all of this migrates down to this dashed line, we like walk up to a wall and we just can't get through it. We never want to touch that wall, and we're never touching this dashed line. If the coordinate lies on that line, not a solution. Okay, something a little more complicated. We have two inequalities that are not in slope-intercept form, so we have to do a little bit of work to get there. So top one, I'm just going to rewrite over here. We've got 3x minus y greater than or equal to 2. I need to get y alone. So let's move our x's. Minus 3x minus negative y greater than or equal to, put the x first. I need to get y alone, and right now it's not. That says negative y. I just wanted to say y. So we can divide by a negative. But remember, when you multiply or divide by a negative, and you're dealing with inequalities, my symbols have to flip. Negative negative gives me the positive, and then positive negative gives me the negative. Now we're left with an inequality that I can handle. Let's do the second one too. I want to rewrite this. I want to simplify that. 3x, let's give it a little space. 3x minus y less than negative 5. Get y alone, so that 3x has to go. Negative y greater than negative 3x 5. I need this to say y equals not negative y, so we need to divide by negative 1. When we do that, the inequality has to flip. 2 negatives is a positive. 2 negatives is a positive. There's our new problem. There's a new inequality that we need to deal with. So let's take a look at the top one. Y-intercept. This time's -2. Start off, find the y-axis. Find -2 on the y-axis. We need to move using the slope of 3/1. Go up 3, 1, 2, 3, run 1. Keep going. 1, 2, 3, over 1. Keep going. 1, 2, 3, over 1. Do we have to keep doing this? No, but it helps us with a nicer line. Solid or dashed line. Do you have an equal sign? Yes. Equal sign means solid. So let's connect them. Now we need to shade. Pick a point, any point, as long as it's not on that green line. I'm going to pick 0, 0 right here. I like 0, 0 just because things cancel out. When I take that and I plug it in back up here, is 0 smaller than or equal to -2? Is 0 smaller than a negative? No, that doesn't make sense. 0 is larger. That means that doesn't make sense. That means we're going to shade in everything to the bottom right over here. Okay. Let's look at the next line. Y-intercept, 5. Find your y-axis, find 5 on it. 1, 2, 3, 4, 5. My slope is 3/1. Go up 3, 1, 2, up. I'm off the graph. Since I'm definitely off the graph, that's not going to be accurate, but I can go in the reverse now. Instead of going up and to the right, let's go down 1, 2, 3, and back 1. And does it look like our 3 coordinates are kind of in line with each other? Yeah, I like that. Let's keep going. 1, 2, 3, back 1. All right. We have our points. Is it going to be a solid or a dashed line? Look at the inequality. No equal sign, so we're going to have dashed. Pick a point, any point that's not on that blue line, not on this blue dashed line. I'm going to go with 0, 0 again. I love 0, 0. When I substitute it in, things cancel. Makes it nice and easy. So take that 0, 0, plug it in. Is 0 bigger than 5? No, 0 is not bigger than 5. That's wrong. That means that's wrong. So all of my answers have to be on the other side here. All right, so let's look at our answer. We have solid line, shade everything this way. Dashed line, shade everything that way. Do our two shaded regions ever overlap? No. Since they never overlap, we still have to show some kind of answer. In this case, we don't have an answer. Well, the answer is that we don't have an answer. No solutions. And that is graphing a system of inequalities.